Hi students, welcome back to this session. In this session, we are going to discuss about Friedman rank test for more than 2 dependent sample. In the last session, we have discussed about Kruskal-Wallis test for more than 2 independent sample. First thing, we are going to describe about the definition. So, Friedman rank test is a non-parametric statistical test used to determine whether there is a significant difference among 3 or more dependent groups. It is appropriate when the data is ordinal or when the assumptions of parametric tests such as repeated measures ANOVA are violated. So, from this definition we can easily understand that Friedman rank test is an alternative to the repeated measures ANOVA. So, under what situation we will use the Friedman rank test? It is better like if the data does not follow any kind of distribution, or if we fail to assume the distribution type of the data, then we can use the Friedman rank test. Next, see about a case scenario. Department of Public Health and Safety monitors whether the measure taken to clean up drinking water were effective. They were using triclomethan in 12 countries, drinking water compared in 3 different situations. One is before cleanup, 1 week later and 2 weeks after the cleanup. And the data set we can see like it has about 12 countries and we have under 3 different situations, and they checked about the quality of the water. Now, we can easily understand they are checking the quality of the water at different times. Next, we can see about the methodology. So, what kind of methodology we are going to follow in the Friedman rank test? Given below is a stepwise procedure to perform Friedman rank test for the correlated samples. First thing, step 1, define the null and alternative hypothesis. What will be the null hypothesis? So, null hypothesis will be there is no difference among the dependent groups, and the alternative hypothesis will be there is a difference among the dependent groups. Next, we see about step 2. So, what we are going to do in step 2? First, collect the data, and how the data should be? Gather the data about the dependent variable from multiple groups. At last, each observation should represent a measurement from the same subject or matched pair across different conditions or at a different point. So, from this we can easily understand that this is an extension of the pair-T test. So, pair-T test is nothing but we are going to collect the data at different times like before and after. If we have only 2 times, then we can use the pair-T test. If suppose we have more than 2 times, let us see we discussed in the example like 1 week later, 2 week later, 3 week later. If we have more than 2 groups, that is dependent groups, then we can use the Friedman rank test. Then step 3 will be ranking the data. So, rank the observation within each group separately. So, you should understand like we are not going to rank it all together. We are going to rank the observation within each group separately. Like if we have 3 groups, we are going to rank it group 1, group 2 and group 3, and assign the lowest rank 1 to the smallest observation and the next rank of 2 to the next smallest observation, and continue the process until you rank all the observation in the sample. If there are ties, suppose if you are coming across the situation as if the 2 observations fighting for a single position, that is multiple observation with the same value, assign the average rank to those observation. So, step 4, calculate the sum of rank for each group. Suppose if we have 3 groups or 4 groups, calculate the rank for each group and sum there. That is, we have to add everything and we have to keep it for each group. This gives you the sum of ranks for each condition or each time point. Then step 5. In step 5, what we are going to do means we are going to calculate the test statistics. So, how to calculate the Friedman test statistics? That is using chi-square. The formula is nothing but chi-square f equal to 12 into summation rj square divided by nk into k plus 1 minus 3n into k plus 1, and we can see about the notation what we used in the formula, where chi-square f is a statistic with a sampling distribution that closely resembles the chi-square distribution with k minus 1 degrees of freedom. And what is rj square? Rj square is nothing but the sum of ranks in the jth condition, and the n is nothing but the overall sample size we use in our data, and k is under what number of condition like 3 groups or 4 groups, that represent the k. Next, step 6. Step 6 is we have to find the critical value. Determine the critical value for the Friedman test based on your desired level of significance. We know that the desired level of significance usually notated as alpha, and the number of groups we already discussed as k, and the total number of observation is nothing but n. Now we can use the statistical table to find the critical value. Now we can see about step 7. In step 7, what we are going to do means compare the observed test statistic to the critical value. If the observed test statistic, that is what we have calculated, will be notated as chi square f is less than or equal to the critical value what we get from the table, then there is no significant difference among the groups, that is 3 different groups, and you fail to reject the null hypothesis. If the observed test statistics xf is greater than the critical value, that is the vice versa condition of the previous condition what we discussed, then we have to conclude that there is a significant difference among the groups, and we reject the null hypothesis in favor of the alternative hypothesis. Then step 8. Step 8 is like post hoc analysis if needed. What actually post hoc analysis is about? If Friedman rank test indicates a significant difference, you can perform post hoc test such as Dunn's test or the Bone-Fournier correction to determine whether the specific groups differ significantly from each other. And in step 9, we have to report the result. Finally, report the result of your analysis including the observed test statistics chi square f, the critical value, whether the null hypothesis was rejected or accepted, and any significant pairwise comparison from post hoc test. So, from step 8 we can easily understand that if suppose we are going to reject the null hypothesis, by rejecting the null hypothesis nothing but there is a difference among 3 different groups. Further, if you want to know what are the difference between the pairwise, for example 1, 2, 3, if suppose we are going to reject the null hypothesis, the result is like 1, 2, 3 are different. But suppose if you want to know the pairwise difference like 1, 2, 1, 3 and 2, 3 among which pair they are differs or not, for that case we can use the post hoc analysis. So far in this session we have discussed about Friedman rank test, the definition about the Friedman rank test, and what are all the steps involved in Friedman rank test, and at last we given the interpretation about the post hoc analysis, and finally we have told about how to calculate the test statistics. In the next session we will be discussing about application of Kruskal-Wallis test and the Friedman rank test. Thank you.